Hi everybody, Marty Geyer here, and this is the second part of Iterative Depth First Search. I want to give everybody a chance at the video lecture to talk about the algorithm. Now again, I don't want everybody to get too used to me digging down too much into the actual code. I do want you to kind of synthesize this information and be able to write the code yourself. But for the purposes of this one, it's kind of complicated. It gives you a good first test case of how to do this process internally and to think about it and how to work through the problem. For future weeks, I do want you to be thinking about this on your own, so you'll see less of the specifics of the code and more of me running through the algorithm and concepts, because that's kind of, more where I'm supposed to be helping you. And you should be able to take these concepts and hopefully, and the algorithms from the book and/or algorithm from me, if necessary, if the book isn't clear on it, or the web, or what have you, and turn it into actual code. But I'm going to help you a little bit here. First thing to note is recursion is absolutely essential here, because depth first search is a recursive function, is a recursive algorithm. And I know a lot of you have some trouble with recursion. It's been a while. I also teach 295 right at the moment, so I know what you're supposed to learn there, but time, memory, etc., and maybe it's not covered as well as it should be. So I realize that some folks might have a deficiency here, so I highly suggest come talk to me if you want to get a brush up on recursion, you have any trouble with the concept, look through web research, look back at your 295 class, etc., to make sure that you're kind of up to speed on this, because you're going to make a mistake somewhere if you're not. It's important to kind of get the prerequisites before we go forward. So without further ado, let me go through kind of explain how this works. So we went through the puzzle. I'm going to kind of stay away from that, other than give you the basics again. We have a 4x4 board with 15 puzzle, 3x3 board with a 8 puzzle. And what we're going to do here is we're going to extract the 2x2 puzzle and the examples that I give, but of course the algorithm works for any of these size boards. In fact, it may be a good idea to write your code in such a way, I know this might be a little bit too late and I should have told you this earlier, but if it's not too expensive a change, it will help for testing to write the board size as generic. So you can make a 2x2 board, a 3x3 board, a 4x4 board, and that way you can actually test on these smaller boards, because on a 2x2 board you can actually find the solution pretty quickly with almost any algorithm, or any algorithm really. So you can tell the algorithm is at least working. On a 4x4 15 puzzle board, it is possible to receive impossible states, etc. You can't find solutions. It's not always visually apparent. It's a much tougher test case. That being said, if it's too much trouble to work things around, I understand. Not sure I'd do it either at this point. Just make sure when you're testing, you test with a lot of different random boards, so that you hopefully will get one that does solve. If you can't get any of them to solve, then that's kind of suspect. You probably have an issue with your algorithm. And you can come to me, ask questions, put some debug code in, kind of work through it. Everybody's code is different, so I'm only so helpful when you send me your code and say, what's wrong? I think I've been able to help a couple of you so far if there's glaringly obvious things, but there's some serious complexity, of course, in the 15 puzzle, and how everybody just wrote their routines for that. So if you have some random bug or some random thing in generating board states, I might not catch that. So it is important that you kind of go through your own debug process and make sure that you can see when you have an issue somewhere. Test all your assumptions that everything's working from previous weeks. Maybe there was a bug in there neither one of us caught, and you need to kind of back up a little bit. So do check everything out. Anyway, without further ado, let's go through the algorithm. So I've kind of written up here. I know that you absolutely cannot see it because the text is too small, but I'm going to read it for you anyway, and hopefully that'll help you. So first you start with a max depth variable and a solve equals false, or some placeholder to tell you that you're not solved. Start with a max depth of 0. Now as we go through here, we're going to iterate over from 0 up. So while the board is not solved, which is not going to be the first time through, we have a big while loop in here, and inside the while loop you have kind of three core things. Reset the board state. First you want to take the board back to whatever state you started with, because while you're doing this recursive down, you might end up at some other state. Now if you do some bookkeeping and stuff, this might not be necessary, but again, it doesn't hurt to have that function. Just to be clear about it in terms of the algorithm. Reset the state back to the first board on each iteration, so you make sure you're going from the fresh board. Then you want to send data to the recursive function. You want to pass board and the max depth, because you're going to need to iterate over the depth. And then you increase the max depth. at the end if this fails. So solve equals recurse the function parameters board max depth, and then increase the depth, and then you go back to the while loop. Now over here, so I'll kind of go through this in a minute and show you kind of a workthrough, so don't worry if you're a little confused at this point still. So the recursive function, remember with recursive functions you have two core pieces. You have base case and the general case, and you want to reduce the problem in each case. So what we're actually going to do is we're going to reverse the problem of what the way I was talking about it in the last video, where we kind of go from depth 0 down 1, 2, 3, etc. And now we're going to go backwards. We're going to call this max depth, whatever max depth is at that particular iteration, and then we're going to reduce it by 1. So on iteration 1, max depth 0, we stop here. Iteration 2, max depth 1, and this is max depth 0. Iteration 2, max depth 2, 1, 0, etc. And the reason why we're doing that is, of course, for the base case. So the base case is if the depth is 0. If the depth is 0, check to see if the board is at the solution. If it is, then you return solve, true, great. Otherwise, you can't go any further because you're at the maximum depth. Depth 0, because again, we're going backwards. Then you return false, back up. So that's the base case. That should always be at the beginning of your recursive function. And the next step then is to generate the board. So I'm just glossing over that. I assume you have a function to do that. If you need help, please do ask me. So you generate the boards, and you loop over each of those generated boards. And again, last time we talked about this, so you'll talk about generating this board, from here, this board, and this board, and then you loop over them. So on this case, generate these two boards. First one we pick, it doesn't really matter, we just randomly pick one first, whatever generation algorithm we're using. We go and recurse the function, now with depth minus 1. So we reduce the depth now. So, and then if that doesn't work, we go on to the next one, check its depth, or recurse the function, and then keep going on any other generated states. If none of those work and you get to the end of all generated states, you return false, which means you go back up because you didn't find the solution. So why does this work? Let's go through it real quick. So depth of 0 to start with. So depth of 0, we start with this board here. And while we're not solved, which we're not, reset the board. It's already reset. Now solve is recurse the function with max depth, which is 0. So we go into this recursive function now. Notice we start at 0, so we're at the base case already. Since we're at 0, we check the board solution. It's not a solution, so we return false. So we return false back up to the main function here. And since we failed, we increase the depth, we're not solved, and we go on. So now we're at max depth 1. Max depth 1, what we do is we go back into the recursive function, now with max depth 1, with the original board again, because we reset it, depth of 1. And depth is not 0 this time, we're not at the base case, so we generate the boards, which would be these two boards here. So generate, pick one at random, or whichever the first one is, which is this one. And now we're going to recurse again the depth of 0. So we make a call back now, because we're at depth 1, the depth minus 1, which is 0, back up here. And then we're in the second recursive iteration now. If depth is 0, which it is in this case, check if it's a solution. If it's not, return false back up. And of course it's not. So then we pop back up to the first function, where we're looping over the boards. And now we looped over one, it's not this one. We check on this one. Same thing, we go back down, depth is now 0, check with the board solution. It's not a board solution, pop back up. And now we've failed to return false at the end of this function, go all the way back up. And now this has failed. So now we got to iterate to depth 2. So depth 2, you go back through. Now I'm not going to stop here because I think you get the idea. So you start with 0, and then you hit depth 1 goes down 1, depth 2 goes down 2, and you recurse the depth down to the bottom where you have a 0. So I hope that helps. Remember, testing is very important here. Recursive functions get kind of hairy, even for those of us that have written a lot of them. So make sure you do some good testing, generate a lot of boards. If it's possible on your algorithm or on your program itself, reduce the problems to the 2x2 board and try to solve it there to make sure your algorithm is working. If I can help you or answer any questions, please do ask me. I hope this has been helpful. Please do tell me if these video lectures are helpful or not helpful. Just a quick email, oh hey, this is great, or wow, that sucks, that's not going to help me at all. In fact, it probably set me back 2 days. I hope that's not the case. But good feedback is good also if these videos are too big, too long, too short, too fast. I don't have video editing software, unfortunately, so that's why these things are kind of clunky. But, I'm kind of quick and dirty trying to get them out for you, so you'll have something at least. If they go well, maybe I can do a little bit better job of putting them together in the future. So I hope you enjoyed it, found it useful, and I'll see you next week.